All right, question number 4. We're going to find the zeros and state the multiplicity. So we have a function h of x as negative 4x squared. And then we have x plus 1. And then we have x minus 2 raised to the third. So this one is already in factor form, which is nice. It'll be easier to find the zeros. We just set each individual factored form equal to 0. Now, even though this has a multiplicity of 3, whenever you do the cube root, you still end up with just the inside set equal to 0. So I'm just going to go to x minus 2 equals 0. Now, I left this part just so you can kind of see what happens to the 4 and everything, but basically you will divide by negative 4. 0 divided by anything is still going to be 0, so now you have x squared equals 0, and then you'll do the square root to get x by itself. You get x equals 0. So you have x equals 0. Now, since it was squared, you have a multiplicity of 2. Here, we just subtract 1, and so we get x equals negative 1. And this one is a multiplicity of 1. It's only 1, 0. And then we would add 2, giving us x equals 2. That came from a cube or third power. So this one is going to have multiplicity 3. So the zeros are 0, negative 1, and 2. The 0 has a multiplicity of 2. And that's, again, coming from the power of that root. Negative 1 has a multiplicity of 1. And the 2 has a multiplicity of 3, and again coming from that exponent of to the third power. All right, number 5, we're going to find all the zeros and state the multiplicity. So we're going to have to factor this one. It's not in factor form. As mentioned on the previous problem, we're going to treat this like quadratic because we see an x to the 4th, and then we have 17x squared. The relationship between these two terms is half, and then plus 1. So this is going to be treated like quadratic. 16 times 1, 16 factors of 16, 1 and 16, 2 and 8, 4 and 4. We want to add to get 17. That would be 16 and 1. So I'm going to write 2 sets of parentheses. Now this is, of course, the set equal to 0. Don't know where the 16 goes, so I'm going to put 16 in both. Now this is wrong. I always mention this, so this is wrong. Let's remind myself. The x there. With the 16, the x to the 4th, we're going to split it up, x squared and x squared. At the back, the two numbers we found, we use 1 and 16. And then we're going to figure out the signs. Well, we needed to add to a negative 17, and that means both numbers need to be negative. All right. Now, this is not right, because if I try to FOIL this back together, 16 times 16 will give us 256, not 16, so I got to reduce and fix what I messed up. So the way we do this is we try to divide these two terms, and we just get rid of that number once we figure it out, the greatest common factor between those. So 16 and 1, nothing in common but 1, so I'm going to bring this term straight down, leave it as is. So 16x squared minus 1. And then over here, both terms are divisible by 16, so if you divide by 16, This becomes a 1, so this just gives me x squared, and then minus 1. So at this point we are factored. If you were to FOIL this back together, you would get what you originally started with. So here's our factored form. Now this is not the answer. We had to get it in factored form so that we could find the zeros and say the multiplicity. What you might notice is that these two terms are perfect squares and we are subtracting. So we're going to do the difference of squares and factor this to find our zeros. So the square root, we're doing the difference of squares. This is 4x and then minus 1. And then we'll have a 4x plus 1. So that comes from here. And then on this side we'll have an x plus 1 and an x minus 1, according to difference of squares formula. Now that we have that, we set each term equal to 0. Add 1, divide by 4. Positive 1 over 4. Subtract 1, divide by 4. So we get these two zeros, each of multiplicity 1, because there's no powers once we had it all factored. And then these two guys, x plus 1 equals 0, which will give us x equals negative 1 when you subtract and solve. And then over here, x minus 1 equals 0, add 1, and we get x equals 1 when you subtract and solve. So 4 zeros, all multiplicity 1. Zeros of f are 1/4, negative 1/4, 1, and negative 1. Each zero had a multiplicity of 1. There was no power once all factored.